Today we're going to talk about how to find the inverses of logarithm and exponential functions. So do me a favor, first of all, make sure you put your name on it, because you will be turning this in at the end of class. It will count as a classwork grade. So let's look at the two problems that we're going to go over today are how to find the inverse of an exponential function and one of a logarithmic function. So first of all, let's remember that an inverse is just where you switch the domain and range. Remember, the domain is the x value and range is the y value. So we've done this with like normal functions, we just haven't done it with exponents and logarithms yet. So for this first one, I know that f of x is really y, right? We've talked about that a few times. So that's going to be my first step, is to switch the x and the y. So this is going to become x equals 10 to the y plus 1 power. So the problem here is I need to solve for y, and it happens to be in an exponent. So what I'm going to do is what we've learned and used a couple of times, how exponents and logarithms can be rewritten. So if you have your notes from a couple of days ago, or just want to jot this down, remember we said if we have log with the base of b of y equals x, that's the same thing as b to the x power equals y. Oops. Okay, so we've written that down a couple of times now. I think this is actually the third time we've written it down. So that's what I'm going to be using on these two problems, because that's what I have here. I have an exponent and I really need to change it to a logarithm. So this is going to change into log with a base of 10, right? Because I can see here that the base of my exponent is the same thing as the base of the logarithm. Then what the exponent is, or what I'm taking, what the exponent is equal to, the x in this case, is what I'm taking the logarithm of. So x equals, and then the actual exponent itself, like here, the actual exponent itself, see that? That's what the logarithm is equal to. So in this case, that's going to be y plus 1. So I just used this right here, super helpful. Again, I need it to be y equals, so I'm going to take and subtract 1 from both sides. And I really can't actually subtract 1 from that, but I can rewrite it as y equals log. Now, since it's a base 10, that means this is a common log, so I'm not going to even bother writing the 10 there, of x, and then minus 1. So that, right there, that is the inverse of f of x equals 10 to the x plus 1 power. Okay, so I just changed it and then I did a little solving. So example 2 is the same thing. I'm still going to be using this right here. So I'm going to be using this, but now I'm doing it backwards, because you can see that I'm given a logarithmic equation this time, right? Again, g of x, that's really just y. So I'm going to start off the same way. I'm going to switch the x and the y. So this is going to become x equals log base 7 of y plus 5. Okay, so the problem this time is the fact that the y is behind the logarithm, and I can't just add, subtract, divide like I normally would in an equation. So what I'm going to do is I'm going to use this stuff to help me rewrite it as an exponent. Okay, but this time we're going backwards, right? We're going from here to here. So I can see the base of my logarithm is a 7. I'm going to kind of write this to the side because I'm totally going to run out of room if I don't. So the base is 7, which would make the base of my exponent a 7, right? The base of the logarithm, the base of the exponent. It's a 7. What the actual exponent is on the outside, right? So I can see that's the x power. And then what I'm taking the logarithm of right here is what my exponent needs to be equal to, in this case, y plus 5. Okay, so all I did was change this into an exponent using our property that we learned before. Okay, so kind of like the last one, I need it to be y by itself, and I see that I'm adding 5. So I'm just going to subtract 5 from both sides. And when I do that, Again, I can't actually subtract the 7 and the 5 because it's 7 to the x power and the 5 is just a 5. So I'm going to get y equals 7 to the x power minus 5. That is the inverse of g of x equals log base 7 of x plus 5. Okay, so that's what I want you to practice trying today. I know that we definitely need practice on changing back and forward from logs to exponents. And if you look, the two examples I gave you are super duper similar to what I just did, so I want to see that you've tried those. And then I want you to flip your paper over, and I actually want you to answer these 3 questions about the graphs that we talked about yesterday. So hopefully you still have those notes, or if you put them in the tray, feel free to go grab them. So I want you to do that and turn that in before you leave class. I hope your Wednesday is great.